Hello everyone. So yeah, now we are going to go through the some of the queries and we'll try to see how the MCP servers are behaving, how the orchestrator is calling the respective agent over the MCP server and their tools to get the queries answered. So here are the list of some queries. Some of them are simple queries, couple of them are medium and complex queries as well. Let's try to see how this is behaving on the given set of queries. So for that, we already started our Docker container and we have also developed a simple UI, chat UI, so which is already hosted. So let's go into that UI. So here is the UI. Now, yeah. So now we can just try to paste our query here at the bottom. You can see and then I have to send it. So again, I have initialized a session and then I have also selected WebSocket, which is like continuous kind of chat. And again, in the streaming mode, so it will also show me how the orchestrator or what is the process that is happening at the backend. Now, when I will hit enter, so it will try to again call the respective MCP orchestrator and the agent. So to visualize that, I have also open the command prompt. Here you can see all the containers that are running. So these are the containers that is running and they are up for some time. Now we have another command stats which tell us the memory utilization of each of these. So here you can see the memory CPU button, CPU compute percentage. So whenever that particular MCP server is getting triggered, the CPU utilization will increase automatically. So from there, we can also understand that these MCP servers are getting utilized instead of they are getting consumed internally directly. So that's the thing I wanted to show here. So let's hit this and we can keep tracking the CPU here. So you can see the Neo4j CPU increase and then graph query also increased. Now we will see these kind of delegation also here. You can see the things are getting delegated and accordingly code analyst got hit and then here you can see graph query again got hit. So this is how the things are happening. So at first like it's analyzing the intent and found that it's a simple lookup kind of thing and the entity it identified which it is going to search in the graph database is fast API. So now step one is orchestrator delegates to the graph query, find the fast API class or entity in the code base. So this is the graph query that it is going to find. And then the graph query agent will find the entity using this MCP tool. And then it will also fetch the get dependencies. So it will also trigger this MCP tool. Then orchestrator will receive this information and then this will pass on this information to the code analyst agent. And then that will inspect the file and it will inspect the entity and then it will generate the final output. So this is what we got as answer. The fast API class is the main entry point to use fast API and it is defined in fast API slash application. So it's also mentioning the file and the line code line where it is explicitly mentioned and from where it hits. So that thing and this is how it is initialized. So this is how we are getting the information and this is the information source which it is retrieving from. Now let's try to run the next query, which is I already wrote this query here. So far it is a satisfactory output, I will say. Coming to the next query, the doc string for the depend function. So again, you can see the uses. So you can see the orchestrator is getting used, then Neo4j getting used, then code analyst getting used. So now here you can see orchestrator delegates to code analyst and then depends retrieved and then code analyst inspect entity and then finally we got this. So this is the kind of docstring that is there. Now let's try to run the next query. This is a medium level query. How does fast API handle request validation? So again we can see the delegation is happening on real time and here we can also see the CPU usage code analyst is getting used. So this is how the MCP servers are getting interacted via the orchestrator and Yeah, once the task is done, then we will get the output and we can go through that output as well. How is it? So here is the output you can see, and you can see it has, I think, gone around these many steps to finally get this answer. So it's mentioning that it's not directly able to find this fast API request, how it handle request validation, but it found out something around that, how FastAI selects and builds the request handler, and that would perform the validation. So mainly it's fetching this routing module and get a routing handler. It's talking about that, and then mm, there are many parameters which it is talking about. So in the conclusion, it's saying that fast API construct or choose the route handler, and but it also it does not include the actual validation logic itself. So kind of a good or average output we are able to get. And here also it's writing the LLM that it is generating the output. So again, in case if LLM is not working, then it will go to the deterministic method that we have kind of fallback. Now let's go to the next query and also see the CPU usage. So what classes inherit from the API router? Now again, you can see the CPU usage here. So we got the answer. This is the route it has taken. And then finally, the transcript doesn't list any class that inherits from it. It only provides information about the API router class itself. So this is the answer that it is able to provide. We can try to rerun this query and see if we get a better answer. Yeah, it is giving the same answer. So let's go to the next query. Try to send it. Again, it is basically find all decorators used in the routing module. So let's see how it is working here. So yeah, we got this output here, and I think it is extracting all the different decorators that are there. So data class Trojan true, data func tool, class method, property. So these are the different data class it's able to decorator is able to find out. So I think it is answering good here. Now let's go to the next question, which is kind of complex query. So let's wait for a couple of seconds. You can track the utilization here. Since it's a complex query, so that's why it's taking little bit more time. And mostly it's triggering the code analyst and the graph query agent. So here is the final output. What it is telling is like from the transcript, the only concrete request handle as well as stops we can ground are the router level dispatch path and the path that is SGI callable. So something is closure Y, I will say. And it's also mentioning what we can't retrieve from the transcript. So we can, of course, work on improving this. But yeah, it's able to fetch some good information. Now, let's run the next query. See, again, we can see the users here. Yeah. So we got the answer here, and yeah, it's a lengthy one. But what was the query is like, how does dependency injection work? And show me examples. So dependency injection is of course represented by dependable and something, and then declaring dependency. This is how it's done. then how we can resolve this, and then resolving dependency at runtime, and then where request handling ties in this, and then examples or code base that it asked for. Finally, the conclusion as well. So I will say this is also a good answer. Now coming to the second last question, which is compare how path and query parameters are implemented. So this is kind of compare scenario which we are trying to do here. Basically, we are trying to compare the difference between path and query. So generally, like path is a kind of required argument that we need to give, while query is something that is good to have. Even if we don't give it, I think uh, it works. So similar kind of output we are trying to get here. So let's see. And parallelly, we can see the CPU uses, how the MCP servers are getting used. And yeah, meanwhile, you can see the sources. I think it's really good. It is telling me which file I need to refer, from where these informations are coming. So this is uh, not something that is creating or hallucinating. So it's also giving us the source information, which is really good, and also telling the exact line where we can find that. It's taking a bit more time. We'll pause the video and we'll wait. It's still running, so let's see how long it is going to take. I think it's going through multiple steps. So let's see if it gives me a good answer. Yes, I think it is able to get some good information here. So meanwhile, we understand it. Let's trigger the next query because it takes a bit of time. And I will also display this. Meanwhile, we can check the answer. So yeah, it's telling from the knowledge graph, both path and query are implemented in this function, which is nice. And then it's saying like a lower level implementation in params where it is getting used, and then where it's present actually, and yeah, what the forward or implementation state looks like. So this is the different argument that we generally give in query if you have used it. And then of course it's telling default value. If the parameter field is not set, this does not affect the path parameter as the value is always required. See, it's telling it's always required. But here it will say it's not set, read more in detail. But yeah, this is something like not very much important. So both here are implemented as wrappers, and that the forward of configuration. The key difference here is the default argument. So paths doesn't affect path parameter. The value is always required, while query is described as the value used when the parameter field is not set. So this is the basic difference. Now, yeah, so I think it's able to answer the complex queries. We can see that. And again, it's triggering the process wise, architecture wise, it is triggering the right MCP tool. So here also we can see the steps it has done and how the orchestrator came in picture in between to synthesize and trigger the different agents to get the correct answer. So mostly we can see it's triggering the graph query or the code analyst agent as and when needed. So yeah, we have the answer I think ready for the last one as well. Yeah. So here it has gone through around 38 steps to get this information. So the question was, what design pattern are used in Fast API core and why? So from the provided transcript, the only design pattern information we can ground in Fast API use of decomposition and delegation to an internal order and middleware stack plus a callable ASGI style in report. And then these are the details around that. And what is not available in the transcript, it also mentioned those. So it's very loyal to what it is able to figure out and what's not. Of course, if the answers are not that much accurate, we can further improve on the internal architecture, especially on the system prompt that we are writing, and some of the handling cases. Or yeah, so these are area of improvement we can focus in near future. But yeah, overall, you can see this is how they are working, and how agents communicate and synthesize. We also saw through the steps that we saw there. Now, monitoring wise, we already checked these. And yeah, if you want to check the logs, that you can do for sure here. Okay, maybe it's not present here, but here in the logs, you can see all those. So this is the timestamp and this is the process, all the MCP calls that has happened. We can visualize it here. So this code analyst, code graph query, then graph query. So all the like calls that have been done are shown here. And this cipher validation we already did in the graph query. So yeah, now since everything is completed, we can just bring down the container. Docker compose down. For now, you can see all the containers are up here. Once I do this down, it will be paused. So you can see one of them, like it is stopping all of them. So with that, thank you, and I hope you like how the queries were getting answered. And yeah, thank you.